Optimizing Object Pascal. A story of optimization. This article originally appeared in Delphi Developer, copyright Pinnacle Publishing Incorporated. All rights reserved. Optimizing Object Pascal. This article examines optimizing Delphi code based on standard techniques, fully understanding the subject matter of the program and a case of sheer dumb luck. A poker library is used to illustrate these points. This is a story about a simple poker library and optimizing code in Delphi. The poker library began as a Turbo Pascal project years ago, one that I had been meaning to convert to Delphi for some time. As it happened, Delphi 5 hit the shelves before I found time to make the conversion. My first step was to redesign the library as an object-oriented project. The original code had been purely procedural. In its new format, the library provides 3 classes for programming poker games. These are, oddly enough, a card class, a deck class and a hand class. The deck and hand are descendants of a card list class. The library supports poker games, which use hands of 5 or more cards, has support for high and low variations and supports wild cards. It was this last feature that proved the most difficult. I ended up building a complete library with no wild card support and used this as the basis for the wild card version. To validate the library, I built a series of 9 test applications. These included programs to test the creation and shuffling of a deck of cards, to allow me to pick any 5 cards and evaluate them as a poker hand, a program that dealt and evaluated 5 card hands of all standard type, a program that did the same for 7 card hands, a video poker game, and 4 benchmarks to test the speed of the library with wild cards and without. It took a couple of weeks to build the library and the process went smoothly. I was able to use a good portion of the old Pascal code. This proved to be both good and bad. Good, because it sped the conversion along. Bad, because I made a small mistake which I will explain later. In another couple of weeks the project was tested and complete except for one small problem. It was too slow to be of any use. Thus begins our adventure. The results of the first speed trials are listed in Table 1. Benchmark hands per second, total time no wild cards 16,490, 157.61 joker 3,453, 830.92 jokers 703, 4,496.7 deuces wild n/a/a table 1. Wildcard library benchmarks. Times are in seconds. Delphi 5 on a 400 MHz Pentium 2 with 128 MB of RAM. The benchmark programs are very simple. Each program creates all possible 5-card hands in a deck of cards. It then calls the setHighValues method of the hand object, which evaluates the hand and returns a high rating and a high name. The high rating is a long integer used as a bit field. The low-order 20 bits contain the ranks of the cards in standard poker order. The high-order 11 bits contain the hand type. For a more detailed explanation, see the library source, which is available for download. This allows a poker program to compare the values of two hands by comparing their high ratings. For example, if hand 1. Rating hand 2. Rating, then the benchmark program uses the high rating to determine the type of hand and keeps account on all standard types and the total number of hands. This serves as further validation of the library routines. In a 52-card standard deck, there are 2,598,960 possible 5-card hands, 4 royal flushes, 5,108 standard flushes, etc. If the benchmark reports different numbers, then we know there is a problem with the evaluation routines. As you can see, each wildcard used leads to roughly an 80% drop in speed. I didn't bother running the deuces wild benchmark. The 2 jokers benchmark took roughly an hour and a quarter to complete. The deuces wild benchmark would have taken an estimated 25 hours to complete. Making it faster, the first step is to find what the problem areas are. The benchmarks themselves point to one area that needs work. The method used to rate wildcard hands amounts to converting the wildcard into all possible replacement cards and then calling the actual evaluation routines. It is clear that this could use some work. To find other areas for improvement, I got out my trusty code profiler. I use Stopwatch, part of Sleuth QA from Turbo Power. There are others available and every programmer should have one. I ran the No Wildcards benchmark under the profiler and waited for the report. Actually, I went to bed. Since the library is a wee bit slow, I ran the profile at night. The next morning, 273 million function calls later, the results were in. See Table 2. Number of calls procedure / function 194,922,000 tcap card list. Get card 14,593,208 swap cards 12,994,800 tcap poker hand. Copy card from deck 7,787,360 is straight. 5,197,916 is straight flush. 4,203,056 sort cards low to high. 3,917,000 rank string. 2,615,028 is flush. 2,598,960 tcap poker hand. Set high values 2,598,960 set high val. No WC table 2. 10 most called routines in the poker library. Stopwatch returns a lot of information. There are timings on every routine called and the percentage of the total this amounts to. In this case, some of the most important information is in the table above. The first thing of note is that there are almost 195 million calls to the get card method. This is expected. Each hand evaluated by the set high values method generates 25 calls to get card. Each call to copy card from deck generates 10 more. The total is correct. So is the total for copy card from deck. Further, a quick glance at the listings indicates there isn't much that can be changed in either of these routines. They are essentially just assignment statements. It's time to think like a poker player instead of a programmer. There are 2,598,960 possible 5-card hands in a standard deck of cards. 40 of these are straight flushes and 4 of the straight flushes are royal flushes. There are 5,108 straights and 10,200 flushes in a standard deck. The numbers of calls to is straight, is flush and especially to is straight flush are way out of line. Every hand is being tested 3 times to see if it is a straight. Actually 2.9633699633699633699963337 times, but why quibble? Set high val. No WC is the workhorse of the poker library for evaluating high hands. It tests each hand passed to it and finds what type it is. Then it formats the hand, gives it a numeric rating and an appropriate name. To do this it calls the isStraight function, and several others. It does this in a nice safe way, with the comparisons ordered from highest to lowest. That is where one of our problems lies. Each hand is tested to see if it is 5 of a kind. If it is, we are done. If not, it is tested to see if it is a royal flush. This means testing to see if it is a straight, a flush, a straight flush, and finally a royal. If it is a royal flush, it checks to see if it is a natural royal or if it uses wild cards. Either way, we are done. If it's not a royal, it is then tested to see if it's a straight flush, so the test for straights is repeated. See the problem? This is a bad algorithm. Optimization 1. Our first improvement is to change the order of the tests. This time, instead of doing it the safe way, I will try to do it the clever way. There are likely to be many solutions. How many ways can 10 tests be arranged? Ouch. Again, it is time to put on my poker hat. Poker hands can be broken down into 2 distinct types. The first type contains 2 or more cards of the same rank. All pairs, 2-pair hands, trips, full houses, 4 of a kind and 5 of a kind hands fall into this category. In the second category are all hands with no cards of matching rank. These include royal flushes, straight flushes, straights, flushes, and high card hands. A high card hand is defined as 5 unrelated cards. This divides the problem into 2 smaller problems. In each case, we want to test a hand against a particular type only once, and we would prefer to test for the rarer hands after the more common. Pseudocode for a partial solution is in Listing 1. Listing 1. Pseudocode for new hand testing order. Test first group. Hands with cards of same rank if is 1 pair, then if is 3 of a kind, then if is 4 of a kind, then if is 5 of a kind, then do 5 of a kind processing, else not 5, but 4 of a kind, do 4 of a kind processing, and else if is full house, then do full house processing, else no, just trips, do 3 of a kind processing, and if is 3 of a kind, no trips. How about 2 pairs? Else if is 2 pairs, then do 2 pair processing, and if is 2 pairs, else do 1 pair processing, and if is 1 pair. This looks like it should perform better, but it has the problem of being a lot trickier to work with. After implementing this, I tested it and fixed the new bugs that were introduced. Using no wild cards, the library could now rate 25,800 hands per second. That's a good improvement. However, it is still not good enough. Benchmarking for 2 wild cards would still take close to an hour, 10 hours for 4. Optimization 2. Going back to the profile, I see that swap cards is being called a lot. So we should check out its code and find the places from which it is being called. The code is plain vanilla. There is no way short of assembly language to make it faster. However, the sorting routine is calling swap cards instead of doing its own swapping. The sort routine is listed below. Procedure: sort cards low to high, var hand, tk evaluation hand, var left card POS, right card POS, integer. Begin for left card POS equals 2 to 5, do for right card POS equals 5, down to left card POS, do if hand right card POS 1. Rank hand right card POS rank, then swap cards. Hand right card POS 1 right card POS, and changing the code to do its own swapping will save a function call each time a swap is made. The sort routine is itself called over 4 million times. That should give us some more speed. It may also be possible to improve the sort itself. I spent a little time trying other algorithms, but the theoretically faster sorts yielded no improvements and in many cases slowed things down. The reason for this is the length of the array combined with the overhead many of the other sorting methods. Optimization 3. Fixing a mistake. It's time to look at the isFlush function and all of its siblings. The code is listed below. Function isFlush, hand, tk evaluation hand boolean, begin result equals false, if hand1.suit equals hand2.suit, and hand1.suit equals hand3.suit, and hand1.suit equals hand4.suit, and hand1.suit equals hand5.suit, then result equals true, and nothing much to do here. Or is there? The hand parameter is an array of records and it is being passed as a standard parameter, which means on the stack. Oops. Dumb mistake. This is code I copied from the original Pascal library. The only changes I made were assigning to the result variable instead of the function name. I did something that wasn't necessary instead of something that would have helped. Making hand a const parameter will improve speed greatly. I then went through the rest of the code to find any arrays, records or strings being passed to functions as standard parameters. Yes, I found a lot of them. With this fixed, the library can evaluate 38,900 hands per second using no wildcards. Using one joker gives a respectable 9,800 hands per second. Optimization 4. I next looked at what the benchmark results are pointing to. Remember that each wildcard is adding about an 80% speed penalty. The reasons for this were explained earlier. I waited to fix it because I hadn't figured out what to do. Let's look at a small part of the code. Wildcards equals number wildcards, hand, case wildcards of 0, not interested in this one, begin one wildcard for WC5 equals CAA club ace to CAA spade king do begin temp hand equals hand, temp hand 5 dot rank equals tk rank, WC5, mod 13, temp hand 5 dot suit equals tk suit, WC5, div 13, do I really need to test all 52 possible cards? It's certainly the safest thing to do, as a first try. It works. But it sure is slow. Time to put on my poker hat again. All 13 ranks must be tested. Do I have to test all 4 suits? No, I don't. Here's why. The only significance the suit has is in determining if the hand is some form of flush. The only way a suit can make a difference is if it matches the suit of the other cards. I can just check one of the non-wild cards and use only that suit. Here's what the new code looks like. Wildcards equals number wildcards, hand, case wildcards of 0, not interested in this one, begin one wildcard set start to start of suit in first card start card POS equals ORD, hand 1 dot suit, asterisk 13, end card POS equals start card POS plus 12, for WC5 equals start card POS to end card POS do begin temp hand equals hand, temp hand 5 dot rank equals tk rank, WC5, mod 13, temp hand 5 dot suit equals tk suit, WC5, div 13. Now instead of testing 52 variants for each wildcard I am only testing 13. This same modification needs to be made for 2 wildcard and 3 wildcard hands as well. The routines for 4 and 5 wildcard hands don't work the same way and don't need to be changed. The speed discrepancy between wildcard and non-wildcard card evaluations has been cut roughly in half. Using one joker, the library now evaluates 22,000 hands per second and 12,000 hands per second with 2 jokers. Optimization 5. The fifth optimization comes from the I'd rather be lucky than good school of programming. I was happy with the speed at this point, so I decided to test the library in other versions of Delphi. I started with Delphi 1. Since the string type in Delphi 1 is fixed and the default declaration is equivalent to a declaration of string 255, I created two new string types. One would hold the card name. The other would hold the hand name. My experience with short strings has been that they are extremely fast. Enterprise would probably like to phase the short string out. Multiple string types complicate implementing the language. Nevertheless, I often use them in my code and I saw no reason not to use them in all versions of the library. This would keep things simple. But I wanted to test them. It turned out to be the single greatest optimization I could make. See Table 3. Compiler time, lower equals better, hand/second, higher equals better, string type Delphi 1 204.6 12705 short, what else? Delphi 222.2 117,001 short Delphi 232.3 80,361 long Delphi 349.9 52,112 short Delphi 370.1 37,057 long Delphi 454.0 48,111 short Delphi 478.5 33,105 long Delphi 523.5 110,759 short M Delphi 543.1 43,094 long Table 3. Standard poker library benchmark. All times are in seconds. All tests were run on a 400 MHz Pentium 2 with 128 MB of RAM. The tests above were made against the standard version of the poker library. Similar speed differences exist in both. Short strings are faster using every version of Delphi. The most striking difference is in Delphi 5. Are short strings always faster? I am told that Delphi 5 converts short strings to the new dynamic strings before performing some operations. This should make short strings slower in those operations. In this case, strings are only used to provide names for cards and hands. This aids in debugging. However, the only manipulations being done are assignments and concatenations. See Table 4 for improvements using the wildcard library. Benchmark hands per second total time no wildcards 97,161 26.71 jokers 66,424 43.22 jokers 41,719 75.8 deuces wild 14 14,016 185.4 Table 4. Wildcard library benchmark. Times are in seconds. Delphi 5 on a 400 MHz Pentium 2 with 128 MB of RAM. What next? The library now appears fast enough. 14,016 hands per second on the slowest test should certainly be fast enough. We know it's fast under Delphi 5. Let's try it out under all versions and see what happens. Table 5 contains the results. Delphi 1, Delphi 2, Delphi 3, Delphi 4, Delphi 5. No wildcards. 12,526 108,920 44,267 40,274 97,160 1 Joker 10,037 69,963 36,770 33,808 66,424 2 Jokers 7,336 43,095 27,846 25,995 41,719 Deuces Wild 2,976 13,590 11,766 11,440 14,016 Table 5. Wildcard library benchmark. Hands per second. Delphi 5 on a 400 MHz Pentium 2 with 128 MB of RAM. A new profile as a final check. We'll run the profiler again and see what we get. See Table 6. Number of calls procedure/function 194,922,000 tcap card list.get card 12,994,800 tcap poker hand.copy card from deck 4,203,056 sort cards low to high 3,917,000 rank string 2,598,960 make aces low 2,598,960 tcap poker hand. Set high values 2,598,960 set high val no WC 1,876,344 swap cards 1,125,312 make aces high 1,098,240 set card order 1 pair. Table 6. 10 most called routines after optimizations. This sure has changed. The good news is that none of the routines seem to be called more than they should. The better news is that it is probably time to stop. The library is fast enough. Could it be faster? Sure. There are several things that still could yield some extra speed. However, there doesn't appear to be anything that will gain any huge increase. From now on, small improvements will be the order of the day. I set up a new folder on my hard drive and copied the finished library there. This would serve as an experimental version, where ideas could be tested without breaking working code. Here are a few of the things I tried with the experimental version that have not made it to the production code. Replacing the sorting routine with an unrolled bubble sort. This creates a long, ugly piece of code but gives a modest speed boost. About 2 to 3%. Replacing the rank string function with an array of constants containing rank names. This also gives a modest increase in speed. Commenting out the card name and hand name fields and associated functions. This yields a 10% speed improvement, at the expense of complicating debugging. Adding $min enum size for compiler directive to 32-bit versions of library. This forces the compiler to make enumerated types 32-bit and adds a small speed increase. Building hands in set high values in sorted order. Bad idea. This slowed things down considerably. Making the swap variable in the sorting routine global. This gives a very tiny speed increase. Making the swap variable in the swap cards routine global. This slowed the program down. Replaced calls to hand naming routines with inline code with mixed results. Doing so for 1 and 2 pair hands sped things up. Adding the 3-of-a-kind routine slowed things down. Puzzling. Finally, I removed the call to make aces low in the high hand evaluating routine. This adds a modest speed boost. Removing the code from the library altogether causes speed to fall. Also puzzling. A problem with code location in memory. Source code for the wildcard library, a companion video poker library, a sample video poker game and all the utilities described in the article can be downloaded from http://charlesappel.home.mindspring.com.